Never before has a man-made object come so near the Sun. The Parker Solar Probe test will give one-of-a-kind estimations and information about our star. Yet, for all the fervor about this task, people are moved by one question. For what reason doesn't the test melt when it's close to the Sun? The Parker Solar Probe occasionally remains in the hottest layer of the Sun, and that is in no way, shape, or form the outer layer of the Sun. It is hottest around the Sun in what is called the corona. In this video, you'll learn how the solar probe is conquering the intense heat and what new insights it will bring. Before we start, we might like to ask you to make a significant contribution to our channel and leave us a comment at the end that fits the subject. From here onward, we will constantly reward our supporters' contributions with a heart. Furthermore, we will pin your educational and advancing comment at the top so that everyone reads it first. Make sure you already have a subscription, like the video, and mention both at the top of your comment. Music. The journey to the Sun, investigating our star, is of utmost importance to us Earthlings. Without the Sun, there is no life on our planet. Our environment and seasons rely upon solar radiation. The activities of the Sun too constantly impact the magnetic field of our planet, and certain people even claim that solar storms have similar confounding effects on the human mind as the full moon. From a purely scientific perspective, space scientists and cosmologists would especially like to learn more about the previously baffling cycles on the surface of the Sun and the corona, which means wreath. This thin glint around our Sun must be seen from Earth with special filters or during a solar eclipse. The corona is an extraordinary secret for researchers until the present time. In this layer, temperatures of up to 1 million degrees Celsius are found several kilometers above the surface. While the temperatures on the outer layer of the Sun are somewhere around 6,000 degrees Celsius, the Sun, like its corona, isn't equally hot everywhere on the outer layer of our star. Constant conflations happen, things bubble up, and forces whirl around. It is similar in the corona. Just there, the heat is as the best molecule mists. These mists or vaporizations are directly impacted by the activities on the outer layer of the Sun. The particles which form the corona are formed by the fiery processes on the Sun or at least affected by them. These connections are not yet known precisely, and it's one of the tasks of the Parker Solar Probe to figure out more about these connections. Behind the impact of the extreme heat development in the Sun's atmosphere must be physical forces and possibly also chemical processes which we don't know about yet. Maybe we might benefit from the test discoveries as to our own energy industry. Just think that the power that you draw from a wall socket generally occurs through the generation of heat. If we were also capable of producing temperatures or heat using the very trick that the Sun uses, we could potentially generate larger sums of energy much more efficiently or increase energy in a simpler manner and possibly in a more ecological way. In addition to studying the massive heat produced in the corona, the probe is, of course, also measuring the renowned solar storms. These are gigantic particle ejections. The winds start in violent eruptions on the surface. During these eruptions, plasma and particle streams are released, which initially float around in the immediate vicinity of the Sun. Eventually, the charges also enter the corona and are freed from the Sun's gravitational pull by a mechanism that is still largely unknown. Then, these particle streams float away from the Sun at extreme speed and out into space. If these particle streams meet the magnetic field of the Earth, this is incredibly disturbed and extended. Scientists believe that such solar winds can override the entire natural force if they reach a certain strength. Solar flares and winds have been intensely studied for less than 100 years. This was enough to find certain rhythms in the eruptions and the winds. The Sun is generally subject to an 11-year cycle. Within this time, eruptions occur in specific patterns. The winds were nearly predictable for a certain period, then suddenly, the behavior of the Sun changed. At first, the activity weakened in an unusual way. Researchers were then concerned, but suddenly the solar activity increased again. These events happened entirely outside the cycles known so far. Thus far, on Earth, we can't be certain that the Sun shows extreme impulses in its behavior from time to time, since this could be dangerous for our increasingly technical world. It's of utmost importance that we learn more about the Sun. A complete loss of power would plunge the planet into indefinable chaos. The Parker Solar Probe has an immensely important scientific mission in many ways. The Parker Solar Probe, launched in August 2018, is a joint project between NASA, ESA, and several other countries. NASA exploited a window of time when the Sun and Earth were especially close, and the probe's trajectory was ideal. Since probes can't go directly toward their destinations, they instead move along the gravitational fields of planets and, eventually, also use their power for forward flight. The Parker Solar Probe previously made 7 laps around Venus before it could set out to arrive at the Sun. Obviously, NASA additionally utilized these flybys of Venus to accumulate a couple of new impressions of Venus itself. In April 2021, the opportunity had arrived. The probe flew through the scorching hot corona of the Sun for the first time, and now you can figure out how it did it. During its flight, the probe drew near 6.1 million kilometers of the Sun's surface. Despite the 2,500 degrees Celsius exterior, the sensitive measuring instruments inside the probe remained at just over 30 degrees Celsius. Worldwide teams of researchers, engineers, and experts spent almost 10 years working on this masterpiece. Key to the probe's success is a refined thermal protection system that incorporates extraordinary materials, a heat shield, the probe's position, and a water-cooled cooling system. The Johns Hopkins Applied Physics Laboratory in Maryland, USA, was responsible for building the water cooling system. The thermal protection system has 2 layers of carbon fiber reinforced carbon, which retains its properties even at the highest temperatures. There is also a carbon foam between these layers, with such large air pockets in these fibers that very little heat is transferred outside. The Parker Solar Probe is entirely encased in white aluminum oxide. The color and material reflect light in an ideal manner, so the outer covering reflects more heat than it absorbs. Between the carbon and the aluminum oxide is a layer of tungsten. This almost white and very thick, heavy metal only melts at a temperature of 5,900 degrees Celsius. Due to the separating layer of tungsten, the outer skin and the carbon layers inside the probe basically cannot react with one another. The heat remains outside, even under the extreme conditions in the Sun's corona. The position and orientation of the probe are adjusted to constantly keep the shield near the outer layer of the Sun, ensuring that the Parker Solar Probe can still gaze straight toward the Sun. Cameras and measurement sensors have been placed so that they scarcely peek out from behind the protective shields. The trip through the outer corona, even on its next flights, will only pass through the outer layers of the corona and only for an extremely limited time. The amount of hot particles with which the probe comes into contact is tiny, so the heat transfer will consequently stay at an average minimum. You can generally compare the probe's journey through the extreme temperatures to reaching into a hot oven. As long as you don't touch the metals or any heated food in the oven, you won't get burned. If your hand stays in the oven for just a short time, the Parker Solar Probe's flight times are specifically designed to correspond to a short stay in the oven. Although the probe was perfectly prepared, the researchers and engineers on the first pass held their breath when the Parker probe remained fully functional on April 28, 2021. Even at temperatures nearing 3,000 degrees Celsius, there was great joy among NASA and all the other involved agencies. At a speed of 586,000 kilometers per hour, the probe briefly rushed through the corona, took initial measurements, shot a burst of particles, and withdrew after a few hours. During the times when the probe is far from the Sun, it occasionally approaches Venus or Mercury. Again, of course, the scientists might want to use these times to investigate these 2 planets closest to the Sun a bit more closely. Also, during these periods, the probe once again uses the gravitational forces of Venus to speed up and set a course toward the Sun with renewed power. The next approach to our star will not happen until 2024. Researchers will need a great deal of patience for this extraordinary mission, but it will be worth the wait. The first results are already exceptional for scientists, and the assessment of the action data will take a while. The probe will probably come closest to the Sun on December 24, 2024. Of all the days for the researchers, it will then truly be Christmas. They can anticipate the exciting measurement data and pictures as a gift. As of now, a total of 5 approaches are planned, the last of which will happen in July 2025. Of course, everyone on Earth hopes that the probe's design will endure all flybys. However, researchers and experts do not expect the probe to be functional for longer than summer 2025. If the Parker probe is still functional at the time of its planned mission, the mission can be extended. The 5 flybys are expected to be sufficient to provide solar experts with the very data they need to make significant discoveries about our star. Thanks to the data, we will know for the first time what is truly happening on the surface of the fuming star, what solar winds are like around the sun, and, of course, what processes contribute to the sun emitting its radiation in specific cycles. The probe was named after the U.S. scientist Eugene Parker. It was he who coined the term solar wind, and Parker is still considered a trailblazer in the field of solar research. Here at Just Space, we'll make sure to stay up with the latest, and we look forward to sharing the most important solar exploration news with you soon. Now, you let us know your thoughts about the Parker probe's design. Do you find it interesting what technology makes it possible, or do you take it for granted? We welcome your feedback and views on solar exploration. And of course, don't forget to mention your subscription in the comment if you have one, and to like the video. We're happy you joined us today, and we'll see you later.